In this video, we will take a look on how we can verify SD-JWT VC credentials based on the IETF standard via OID4VP using the walt.id community stack Verify API as well as the walt.id portal. First, we will take a look at the walt.id portal, which is a UI you can use to verify SD-JWT VC credentials easily. Later, we will take a look at the API, which is working behind the scenes of the portal to see how we can configure different types of verification requests to verify SD-JWT VCs. Now, also, we will need a wallet, and here I will use the walt.id web wallet. I've already issued myself an SD-JWT VC credential. We can see here the attributes which are selectively disclosable, and also if we show here the credential JSON, we can see more information about this credential. For example, its type, but also the key of the holder, so my keys in this instance, to which this credential is bound. Also the issuer did, to then later verify the signature of this credential by the verifier to know that this was actually issued by this issuer, and other information. Let's now go to the walt.id web portal and see how we can verify one of those credentials. Here in the portal, I will now search for the identity credential I have in my wallet and start the process. I will click here on the verification tab, select IETF as the credential format, select all the policies that I want to apply against this credential, and click verify. This will create an authorization request in the background. And we can also take a look by copying this here and pasting it in an URL decoder. So if we decode this URL, we will see that this is an authorization request coming from the walt.id verifier demo, which is running in the background, so our Verify API. And we can also inspect here the presentation definition URI by opening this up and taking a look. So every time you create a verification request, this presentation definition is required in order for the wallet to know which types of credential it actually should present to the verifier. First of all, we know that we will request a credential which is based on the SD-JWT VC IETF standard, and we will want a credential of the VCT type identity credential. Now, if we go quickly to my wallet, we see that this is actually the type I have right here. So when we now take this original authorization request and we paste it in my wallet, now using here the same device flow by providing this URL directly or via a link. But you could also, if you have the wallet, for example, on your mobile phone, just scan this QR code here, which is just a rendered out version of the request URL we saw before. So this right here. When I now present this credential, I can select which of the selectively disclosable attributes I want to now share with the verifier. And in this instance, I won't disclose any of them. And now here we successfully presented the verifiable credential. Let's now go over to the API and see how we can achieve the same thing. Here in the Verify API of the community stack, we will focus on two specific endpoints. One is to create the authorization request, so to request the credential from a wallet. The other one is then to later check the session and verify if the credential presentation was successful and passed of all our selected policies or not. The other endpoints, especially here the OID-C endpoints, we don't need to worry about too much because these are just protocol endpoints that need to be there in order for the wallet and the verifier to communicate, but we won't be interacting with them. Also, the others are more for specific ecosystems like EPSI or integrations like Entra. So let's now focus on these two endpoints. First, starting with the OID4VP Verify endpoint. Here we can configure first the authorization-based URL, which we leave as is for most use cases. Then the response type direct post, the success redirect URI, error redirect URI. So if, for example, we want the wallet to redirect the user to a specific URL at the case of success or error, we can provide these URLs here. We can also provide a callback URI with an API key. So in case of an external system that needs to get notified on the different stages of the verification request, we can provide this here like a webhook. This API key will then just be provided in the bearer header of the request which is sent to this callback URI. We can customize here the state ID, and here we can also select a specific OID4VP profile. In our case, we will just use the default one, which works for the SD-JWT VC IETF. Then we can also optionally set a specific session length, how long this OID4VP authorization request will live for. The default will be 5 minutes. Let's now go ahead and look at the body, where we now will configure our verification request. Now here we can see a basic format, like a basic request, where we just provide the format of the credential we want to request and the type. So our format in that case is VC plus SD minus JWT. And the VCT is the one which we already saw before. And so if we go quickly back to my wallet and look at the credential, we see the VCT here, which we would need to provide in this request. Now, when I execute this, what will happen is that the community-sig verifier API will take this and will turn it into a presentation definition, what we have seen earlier. And so when we now take this authorization request, which gets generated, and paste it again here in the decoding tool, and then open up this presentation definition URI, we will see the presentation definition that was generated by the Verifier API. And that it here specifies the format again of the credential we are requesting, as well as the pattern, so the type VCT that needs to be matched. Now, when we take this and now provide this to the wallet, leave the default disclosures, so nothing specific. I will just disclose what is already disclosed. We see that the presentation was successful. Now, what does actually happen when the wallet presents a credential? So the verifier creates this authorization request, and the wallet will respond with a so-called VP token. And this VP token will include the credential or credentials that were requested by the verifier in its original JWT format, but also a key binding JWT. So a JWT that proves that the wallet presenting the credential actually owns the keys to which the credential it presents are bound. Now, when we quickly take a look here at the identity credential, we see that here, so this is the public key of the holder of this credential. And when we now go back to our verifier API and look at the state value here, copy the state value out, and then use this other endpoint to request the results of the presentation, and we scroll down a little bit here, we will see the token response, where we see this VP token that the wallet responded with. Now, when we take this VP token and paste it here in this JWT SD-JWT tool, we can see that we have here a key binding signature, and we can actually also extract this key binding JWT from this JWT here, because these are just multiple JWTs appended to each other. And so when we look here for the tilde sign, you see here we have this JWT, so this first JWT, and when we copy this out, paste it here in JWT.io, we see that this is actually the credential which was issued to the holder. So this right here. Now we can take this and we can verify that this credential based on its signature was actually issued by the specified issuer here, which is also seen here. But this doesn't prove yet that this credential was actually, like the presenter of this credential actually owns this credential, because we would need to verify like some kind of message, some kind of signature that was signed by this specific holder here to which this credential is bound. And that's where this key binding JWT comes in. And so if we go back quickly here and use the second JWT and paste it here in JWT.io, we see, first of all, here the key ID. So this key ID, when we quickly go back and take our first example, now when we search for this key ID, so the key ID which signed this key binding JWT, we see that this is actually the key ID of the owner of this credential. And so also what we see is a nonce here, which is provided, which again is the nonce which we provided here in the verifier, in this authorization request generated by the verifier. And so this key binding chart, we can now verify that the presented credential is actually owned by the wallet which presented it. Now, what we did was a basic verification request. A basic verification request in that sense that we only applied the signature policy, which checks the signature of the charts, that this was issued by the issuer and that it was also presented by the wallet which actually owns the credential. But we can go beyond this because we do have different types of policies which you can apply to credentials that you are requesting. And you can also find these policies if you go to our documentation under the verifier section. You can see an overview of different types of static policies we have, where we also can see the signature policy, parameterized policies like the webhook policy, where you can send off the whole presentation, so this VP token, to an external system, and then you can do whatever you want in terms of verifying, and then you just respond with a success or an error. Now, what I will do now is customize a bit the verification request. And this time, I'm not relying on the Verify API to generate this presentation definition for me. So this one right here, which we got out from our last request, but I will create it myself. Now, when we take a look here, what we will see is, we request this format, SD-JWT VC. We have seen before the VCT type. Now here, but in the constraints, I'm not only filtering and asking for a credential that has this pattern. I'm asking for a credential that has a birth date attribute, and this is also required to be there. Now, in order to enforce whatever I'm specifying here during the verification, I need to apply a specific policy, which is the presentation definition policy, which makes sure that this is actually fulfilled by whatever the wallet gives us back to the verifier. Then I also specify two policies, so not before and expired policies, which should be applied to the VC. So VC policies here apply to all credentials we are requesting. So if I would request now another credential, these policies would also be applied to the other credential. I could also specify them in the credential request here, and so these would then only be applied for this specific credential and not another one if I would add that. You can also learn more about different formattings of these requests in our documentation. But let's now execute this here and create another authorization request. Now, maybe before we provide this here in the wallet to present a credential, we see here birth date is actually a selectively disclosable attribute. And so here I'm requesting this to be present. So what will happen if I just now present this and here I don't disclose this information? We can already see that the presentation definition policy we specified here failed because I didn't disclose this birthday attribute. But we can also quickly take a look here in the results to check the details. So here we see the verification failed. Here we have our VP we already know. And here we see that the presentation definition failed. Now we see that not before, so the other policies we provided, not before, that was successful and the expired was also successful. But because one policy failed, the whole presentation or the whole verification process failed. Now, let's do one other test, and this time I will expose the birth date field. So another authorization request, I presented via the wallet, I disclose birth date, and here we have it. So presentation was successful as I disclosed it, and so the presentation definition we created was fulfilled. And so when we now check out this result again, we see also here that the verification result is true, and our presentation definition policy also succeeded. Now, if you want to learn more and have a walkthrough of these different types of requests, you can check out the links in the description. Like and subscribe if you enjoyed this video. And with that, happy building and see you next time.